Good afternoon. We're going to get started here. Thanks everybody for coming out and being part of this incredible panel on this new thing called artificial intelligence and data. So we have a pretty unique panel here, which I helped construct, which involved uh, various aspects. The objective of panels are to get various perspectives from stakeholders in delivering our mission. On my immediate right is Colonel Chase Hasbrook, who serves as the Chief of Forensics and Malware Analysis at the U.S. Army Cyber Command, where he leads the Army's premier forensics and malware analysis lab. Next, yeah, clapping, clap. Just kidding, just kidding, just kidding. Next to him is Miss Laurie Jansen, NSC, who is a distinguished cybersecurity leader. She is the director of external cyber assessments at Blue Voyant, and she was ex-NSA, which included positions like National Cyber Threat Operations Center, and counterterrorism mission management. And finally, we have on her right, Colonel Glando, is currently the Director of Cyberspace Security, and he is Senior Cyberspace Security Strategist at Athena Technology Group. And with that, I'd like to kick it off. My name is Shivaji Sengupta. I'm the CEO of NextKey Corporation. As a company, we do similar cybersecurity work at 10 agencies. And so the heading of this panel can be a little confusing to some. I've been told at this conference today, we're all here because of AI, but I keep reiterating AI is literally, in my humble opinion, useless without quality data. And what we're trying to address on this panel today is the role of securing our data supply chain towards the end goal of having authoritative data on which our AI system can make those, provide us quality responses and feedback and outcomes. So with that, I'd like to kick this off. Colonel Hasbrook, if you could help us understand, in your mission space, how do you see the role of quality data, and how have we evolved from 5 years ago when Colonel Glando left us?
Okay, so those of you who know me know that I rant about this topic quite a bit. Data quality in my work doing incident response is incredibly important for a lot of reasons. I can tell you back when I was doing incident response in the 2020, 2021 timeframe, we would do lots of responses to various incidents where we frankly would come back to the commander and say, we can only give you a low confidence assessment because we have so many gaps in our data coverage across the Army enterprise. One of the things that I was really happy to kick off in my time then was really try to kick off a enterprise initiative within the Army that was modeled on the White House and OMB's directive on cybersecurity data, which kind of set out a lot of the fields to collect and what should be in those fields and how to collect all those things and some specifications. Then we promptly ran into some problems along the way that, once somebody writes something and puts it on paper and pushes it out in an order, that does not necessarily mean that people are actually going to follow it down the line. So then the next few years after I left, Army Cyber has done some really good work with making this an enduring mission and trying to really work on the data, make it part of the mission set across the force, and move to a hierarchy where they are, not just collecting data as a one-time collection, but auditing the data as they receive it across the force to make sure that, one, it meets everything it's supposed to meet, and two, that it doesn't just disappear en route. Lots of times, you don't find an incident because it turns out your data collection just stopped 2 years ago and nobody ever checked to see what had happened with that. So we've made a lot of progress enterprise-wide in actually fixing that.
Thank you. Colonel Glando, can you help us understand what could be some of the tactical ways we can actually address that, the whole concept of having our data being parked, which comes over the wire, and how can we continuous monitoring, continuous improvement?
Thanks. So I'm gonna try to explain it from a big picture down to a little picture on this. So just kind of give you a little bit of background first. So as you already heard up front, I coded in Lisp. Lisp is a knowledge base programming language, and really designed what we called back then an expert system. So with that said, and just put a plug in there if you want to learn more about Lisp, Google, Back to the Future, Dr. Men Hekar, he just gave a really good brief in Europe back in May. So if you want to learn a little bit more about Lisp. But anyways, going back to answer the question, one of the things that I designed in this particular program is, first of all, you have to understand what the requirement. What is the AI system supposed to do for you? Well, I was like a second lieutenant at that time, so I'm showing my age here. And when I wrote that program, it was designed to enable a patrol leader to make a decision as they crossed a danger area. And I was very interested about that at that time. If you know much about Lisp, or it's very similar, they have knowledge graphs. It's very similar to Python with the libraries and that. So it comes back down to the data source. You must have reliable data that has already been vetted, validated, and verified. So I had 3 buckets of data that I looked at, right? The first bucket of data was Army doctrine, doctrinal way to cross a danger area. The second one is you go back to the Army call center. All the AERs have been published there, so the AI system would reach out to those 2 particular libraries, and again, the Army calls database or library has to be vetted, validated, and verified. And then the third thing was, the system that we did pull data was live data. And so the platoon leader or patrol leader would have a heads-up display, and as they were walking into a particular danger area, the heads-up display with satellite imagery coming down and feeding the AI system would read it, and then automatically assess the situation for that patrol leader and provide the best recommendation. So, hopefully that answered the question on securing the data source with reliable data.
Sure, Colonel Mando. And just to move on, Laurie, for the benefit of our audience, what frameworks are you most familiar with when you're working in the NSA, partnering with the Army Cyber Command? If you can just enlighten our audience about some of the frameworks or best practices that you leveraged.
So fundamentally, AI is data, right? Data science. We've been using data since the dawn of intelligence, the dawn of the government, the dawn of military. All of these things that we have had inherently and have transformed into be cyber doctrine is fundamentally about information assurance and then cyber defense. And we could go through all the frameworks. Looking across the room, that is not why you're here. What we want to know is, how do we adopt and utilize AI in a way that is going to be transformative, right? There's a lot of power to it, and everybody can agree that we do not have enough resources. And so I think that's why we have this period of time where we talked a lot today about this. The adoption of AI has sort of overdriven the governance of it. So the frameworks are fine, all of that is fine, but really fundamentally, I think we need to redefine and redesign how we're going to use this type of data. If we continue to use the old frameworks and impart them on AI modeling and things like that, I think the foundational security of it would be good if that's how we were using it. But in actuality, there's benefits that the current system will be prohibitive for us to move forward in a innovative way. So my experience and how we used AI majority in the government and in my early time was in human language translation. That's my background. So it's important to understand what both of my colleagues have talked about is the quality of data and the value of data that you are using and imparting into your mission space. And for language translation, just to give you an idea of how you need to, what type of training you need to do, it's 1,000 hours of translation from a specific language to get 10 minutes of quality translation. So that's just, one piece of AI and one piece of machine learning. Now, compare that to the enormity of data that you need to train your model on to get just one answer to one question. So, if that answered the question, yes, we have many, many things that people are trying to do, but again, we have definitely outpaced our governance. Where do we need to go? I think communally, we need to talk about what are the ways that we can use the data in a way that obviously adheres to privacy and security, but also to be innovative and be able to be at the same pace that our adversaries are ingesting and using this type of data.
No, very cool. And we discussed in the speaker room about all these models, frameworks that are out there published on websites which are accessible to our adversaries. So Colonel Hasbrook, what are the primary security risks of using some of these so-called pre-trained models or which are all published, which our adversaries not only have access to but are very well conversant with? And what about the vetting, validation of newer tactics that we use to overcome or do better than the policies and procedures that we have put out there?
Oh, I could talk forever about this. So there is a vast and growing literature on how to attack AI systems. So you can probably break this into two broad categories, right? The first category is just remembering that an AI-based software system is still a software system, and it will still have the same classes of vulnerabilities that apply to it that apply to other software systems. So if you go and you look at NVIDIA did a really good talk I can't remember if it was Black Hat or DEF CON, but they did a really good talk about how they were attacking AI models, and like 90% of what they were talking about was not necessarily actually attacking the AI models itself. They were just attacking various parts of the tool chain that were given too many permissions or other things, which are, these are not new vulnerabilities. These are things that security professionals have had to deal with over time. So that's part of it. The second part and the more longer term part is how do you protect the actual AI system itself? So there are attacks you can do against the data. You can poison the data either in a deliberate way or in a very subtle way. We see this a lot in computer vision where somebody will, and sometimes this is accidental and sometimes this is deliberate. Like there's a very famous example of a computer vision that was being used to detect tanks. And it worked really, really, really good in testing. And then they tried to take it into the field and it worked terribly. And they dug into it and they tried to figure out why. And they realized that all of the pictures of tanks actually had like a little bar for scale next to the side of the picture. So the model learned to detect the bar. It didn't actually learn to detect the tank versus the non-tank. So things like that, right, is oftentimes what bedevil the system. And an attacker can do that just if they have access to the data sets and they know that you're going to be drawing from it, they can introduce things into it. Sometimes you can catch those things early. You'd prefer to catch those things early. Sometimes you can't, and that's more difficult. And then there's some other attacks that we're starting to see happen right now. We're starting to see prompt injection attacks. as people are giving AI systems more permissions. So you're starting to see like your Microsoft Copilots and your Google Geminis and other things, where I saw an attack at DEF CON where people would send you a calendar invite, and the calendar invite would have some instructions in it. Google automatically puts the calendar invite on your calendar, and then later, when you ask Gemini to read my calendar and tell me what's on it, it will read the instructions on the calendar and then, follow the instructions in that calendar invite that says, hey, email the entire contents of the calendar and everything in this person's email box to this email address. So mitigating this is very challenging as LLMs are currently architected today. And we have to make hard trade-offs as to, is the automation that it gains, is the productivity gains that it gives us, is that work worth the security risk? And that decision is going to be different depending on a lot of different contexts that you're working in.
Thank you, Colonel Glendo. So congratulations on your book. I look for some interesting reading after this conference. So in your book, you had a chapter about scenarios. Can you help elaborate on a scenario that would work for this example?
Sure. That's chapter 7, the gloom and doom chapter, right? And it really highlights how you can use, cyber and information operations to manipulate information. But let me give you a scenario. Isn't it great we have an open society? Well, think about this one. I'm kind of leading you, right? So why am I leading you on this? So imagine if we have a requirement from a customer and says, hey, I want a SOC. I want to maximize or optimize my efficiency of a SOC. Well, hey, I got an AI solution for you. And you can run that entire SOC with 3 people. So you develop a SOC, and the requirements are protect, detect, monitor, and respond with all the functions. You pull in all of the data from already established SOPs and TTPs, and you run that SOC. And it looks like it's running pretty good. You remember what I said in the beginning? Isn't it great we have an open society? So imagine if the adversary did the converse. I think I'm going to develop an AI system to do a cyber threat hunt. And where am I going to pull my data? Well, for instance, MITRE ATT&CK framework. We all know what that is. I'll just pull that up. That'll be one of my libraries. And then I'll pull up all the TTPs for an APT, Advanced Persistent Threat. Pull all that up. I'll pull up another library for all the CVEs, right? And then maybe I pull up I establish a library that does live data. So as I conduct my reconnaissance against that particular AI against AI, which is also interesting, an AI system actually conducting a cyber threat hunt against an AI SOC. And as it's learning how to get in there, has anybody been to the JNAC course? Or kind of old school? Yeah. So one of the key things is they teach you is how to recon all the way to the target, and you find that path of least resistance. So if for instance, and the AI system will learn this much faster than what a human will, you will recon a target, and let's say you come to a switch, and that switch has a firmware that's been outdated, and you know what the vulnerability is, and you already have an exploit for it. That's part of your package. Call it your strike package, call it your cyber package, whatever it is, but that's your package. And then you get closer and closer to the target until you finally get to the target. And then you establish your backdoors and your race, do all the standard stuff that you're supposed to do to gain access to that particular target. Well, that's what the AI system is doing. So that's kind of the gloom and doom scenario. Yes, AI can be beneficial with defending our networks, but at the same time, the adversary doesn't have to play by our rules, right? And we are an open society, and they can gain everything just by Googling it. So,
great point, Colonel. I sometimes call cybersecurity a labor arbitrage war. We can have 24 warriors working 24/7. The PRC has 24 buildings full of people doing the same thing at the same cost. But talking about that, Colonel, if you can help us, what kind of strategies, you can use, if you can just name one strategy that's most successful to protect a data supply chain?
So protecting the data supply chain, that is a huge challenge and something we are absolutely still trying to figure out. I talked a good bit about protecting data quality before. So here I'll just riff on that a little bit and say that it's really important to think about, where are you getting your data from, and where did that particular location, where did it get its data from, and so on and so on. So we're used to, in the security space, talking about vendor risk and assessing second-party risk, third-party risk, and then on and on down the chain. Well, soon we're going to have to do this for data as well. So where did I acquire the data? Did I acquire it internally? Did I acquire it from a vendor? Well, okay, then where did that vendor acquire the data? Did they acquire it from one of their subcontractors, and so on? Because in the end, if you are reliant on that data to make critical decisions, then you need to actually be able to verify that data is correct. And if it comes through a bunch of different sources, then you're not going to be able to do that anymore.
Thanks, Colonel. So, Laurie, you spoke earlier about governance. What are your thoughts about how can organizations maintain effective security and data governance over AI systems?
So both my colleagues have talked about really fundamental and foundational things, and that is, as we ingest this data, we are inherently trusting it. And like Lieutenant Colonel Hasbrook talked about, where did your data come from? Are we maintaining a clear understanding of that? There's some really profound statistics that you can all Google or chat GPT out there, and that is essentially a third of the public models that you're going to download are going to have a built-in exploit. To Bryant's point, our adversaries understand that we are trying to incorporate and use this type of data, and they understand that we're doing it at a massive scale. Likewise, like Lieutenant Colonel Hasbro talked about, they're also orchestrating campaigns against that to poison the data, to not only poison the data in an active campaign, but to poison the data in a way that, with the hopes that they will insert some type of information into a particular data set that may or may not eventually end up in a place where they want to gain the information. And what I mean by that, and the research that is clearly evident of that, is that particularly APTs or nation states are inserting some type of code or things like that, that when normal users incorporate that into their AI, or into their organization, or using it in their own AI modeling, it may not execute in any way for like 90% of the users, but there may be a potential that that data will end up in a place where, when executed, it will actually cause some type of effect in the threat actors space, hopefully catastrophic, right? So what we need to understand, and to the governance piece of it, is that we need to treat this data just like we would treat any device, system, anything that we were inserting into our own organization. We need to treat it the same way. We need to verify where it came from. We need to validate that it is what we think it is. We need to continuously tag to make sure that we know where it came from, so that if something does happen, we know how to get back to it. Again, the expansive use of these models, most organizations, especially if you're a large organization, it's going to be used here and then there, and these models are going to continue to learn and adapt and grow for your organizational mission. But you have to understand, like we do with anything, that you wouldn't just take this is cybersecurity 101. You wouldn't just take a series of phones that you got from somewhere and insert it into your network. You just wouldn't plug them in and use them. But we're doing that essentially with a lot of models. And so what we need to do, again, the outpacing piece that I talked about, is we need to step back and say, where did we get the data? What's the intended use of the data? Are there critical pieces of our infrastructure that we should not be using the data on? And how much trust should we build in to the things that we're doing. Because like any organization, you have different layers of your mission. You have very critical tasks that contain very critical information, and then you have mundane tasks. So we just need to step back and evaluate what is our intended use of these AI data sets, these models, and what are the repercussions, knowing full well that our adversaries are also understanding AI models, understanding the utilization of it, because they are also incorporating it, and really just use foundational good security practices as we navigate the space and the adoption of all of this stuff.
Thanks, Laurie. So I think one of the biggest challenges is, and we spoke about this earlier, is getting to this utopian stage of authoritative data in an entire data lake is something we may not achieve in our generation. And obviously there are multiple tranches we want to go through over the next X number of years. But Colonel Hasbrook, if you can just elaborate on some of the challenges of how to balance the benefits or requirement for operational data and then an ongoing program to get our data lakes to that authoritative data state. Is that even possible? Will we ever get there? And how do we keep delivering on our mission if we just
Sure.
keep spinning in circles?
Yeah, so a fully optimized data lake is a utopia, like the single pane of glass that we keep talking about. So spoiler, we don't have a single pane of glass. We will likely never have a single pane of glass, despite everybody telling you that you will have one. It's an idealized state that you would like to get to, but likely are not going to. So what we've seen from industry, and I think here in enterprise, we are slowly starting to follow the model of some of what we're seeing from industry, is that it kind of follows a trend where you first start talking about, okay, we need a data lake where we bring in all of our data and we capture it in that one central location so we can run analytics against it. And then once you do that, you start realizing, oh, wait, I have way more data than I thought. And so now I have to make some really hard choices about which data I choose to collect and not to collect, or how far back do I keep and hold on to that data? Am I willing to incur that cost? So we're doing some of that now. And we're also looking at, do we necessarily need to incur the costs needed to transport the data, right? Does all of this data need to contiguously live within one centralized lake, or can you have a bunch of different discontinuous data warehouses, and then you just put the logical layer over top of them that can reach down and access those data warehouses as they need to be able to run the queries as you need? So I guess there's no one right answer to the question. It's really dependent on, is it more costly and more efficient to centralize the data and incur the costs required to bring all that data together, or is it more efficient to incur the cost at the time that you're querying against that data source? So absolutely very use case dependent.
Thank you, Colonel. But my money is on Colonel Glando because he wrote a book about this. So, Colonel Glando, maybe you can help us with some solutions.
So I'm actually going to give an experience when I was still in uniform and I was up at U.S. Cyber Command. I was the J-35, and I had the honor, I guess, of helping to develop cyber strike packages for offensive cyber. The challenge here is, when you put together a strike package and you have a capability to do X, Y, Z, whatever that may be, it really does come back to what I said on the 3 Vs. You got to vet it. Who are the other stakeholders? Who has equities? Who has a stake in this? And you gotta get buy-in from all of them. And trust me, there's quite a few. Verify. Is that target still there? Because, the adversary always has a voice. So if they know that you've already targeted, well, this is a cyber target, and maybe that target might move. And then, is it a valid target? We got rules, the law of war, right? Our adversaries don't. So if we launch a cyber strike package that takes down a target, right? And we think it's target A. But in reality, somehow they got into our, let's say this was an entire AI system now, right, to expedite the entire strike package. And they got into that AI system and corrupted the database or corrupted the actual program itself, the code. And we don't hit target A, but we hit target B. And suddenly you're taking down a hospital, for instance. Imagine the blowback from that. Well, there's also another piece when it comes to the authority piece. And I don't know, whoever has dealt with lawyers. Any lawyers here, by the way? I didn't do it. Anyways, the last piece of that whole puzzle is getting the lawyer's approval to push that button and do that strike. Now think about this. If that was an AI system and it's got a nice library, and we were just talking about this, and we had a library that had all the policies and all the laws and all the FISA and all the NSA, all the stuff in there. And that AI system went ahead and said, yep, we're good to go, let's fire. But what if it was corrupted? And now we launch and we hit target B. So, sorry, I'm always the gloom and doom guy here, but anyways, verify, validate.
So the DoD will spend millions of dollars to build a system so that it can avoid talking to a lawyer if it has to.
I do have one quick add on the authoritative data lake thing. I think the other problem is we're looking for this enormous data repository that's going to fit all of the missions or the functions of our organizations, when in actuality, it's more important to have representative data than to have just more data. And an example of this was there's self-driving vehicles, and they reduced their accident rate by 15% by inserting 3% more nighttime data. So what does that tell you? The issue is not necessarily the vehicle, it's that the models were trained on only probably daytime driving. So I think to the point of authoritative sources or authoritative data lakes, we need to step back and say, what is the type of data that we need? Are we feeding the models in the way that we need to? And is the output representative of what we're trying to achieve for the function of that particular AI data? And in many cases, I think we could say, no, more data is not going to solve all of your problems. The right type of data that is accurate, that does not have inherited bias, is going to be more informative and helpful for your function and the utility of using those AI models than just saying, I want more data, I want more data. We talked a little bit about it earlier too, knowing where the data is coming from and ensuring that the data is what you are actually looking for to correctly represent what you're trying to have as an outcome is very important. Something that we've seen is vernacular, right? Words mean different things in different sectors. So if you have a ton of data that is representative of the financial sector or financial data, but what you're really trying to do is drive cybersecurity outcomes, potentially your vernacular is going to distort the outcomes of those things. So I think, again, an authoritative data source is very utopian. I think we need to scope these things a little bit more and really push for modeling that is effective, reliable, and relevant to what we're trying to do.
Thank you, Laurie. So let me start from you, Colonel Hasbrook, is that just for the geeks out there, can we, what kind of security, we're talking about validation, verify, what kind of tools have you leveraged across your lifetime to achieve those milestones of data integrity? Do you have any thoughts, methods?
Yeah, so thinking about data integrity, so one of the tools that we used, and this is where I would probably defer to some of the more data people that we have at Army Cyber, but in the early days where there were no data experts and it was just me and my team who were trying to figure this out, not because we wanted to necessarily solve data holistically, but because we wanted to solve incidents, and we kept getting really upset that we couldn't get good data on incidents because our data was bad. So one of the things we would do was try to actually write parsers that would check the length of various fields and see, one, are we receiving the data at the times that we were supposed to receive it? Two, is it the length that it's supposed to be? Which is checks that you can do. This was, pre like LLMs or anything like that. So this is just very basic, like, detection rules that you can write in basic code. And once we put that in, that was able to fix a lot of the, this one geographic location in the world, they were pushing data, but then they made a configuration change and they stopped pushing data and nobody caught it because nobody was checking for it on the far side. So it just stopped being, processed. And then there was an incident, but it turns out you had a gap and you didn't see the data. Or, the other thing that happened is same thing, configuration change, and what used to be aggregated data from 5,000 different hosts and all of their event IDs, to be more specific, all of a sudden it became 50 hosts because they put in a truncation filter that truncated like 99% of the data. But the first pass of the auditing mechanism that we put in place, it just checked to make sure that we were receiving data, but didn't check to make sure it was the length that we desired. And we got burned by that as well.
Colonel Lando, being the geek you are, because you're wearing socks, which shows that you're a geek, how? You have anything to add to that?
Yeah, one of the things I've thought about and really going back old school again, to ensure, the data is secure. I just want to go to the coding side of it real quick. So one of the things, everybody's heard human in the loop. Everybody's heard kill chain. And, and I hope people know this, Asimov's 3 laws of robotics. So you almost have to design embedded into the original code, 3 laws like that. And I'll just tell you what they are real quick. Cannot harm a human being, right? Through action or inaction. Second, must obey a human being unless it conflicts with rule 1. And then the third thing is must protect itself, own existence, unless it conflicts with 1 and 2. So think about that and apply that to an artificial intelligence system. I like the human in the loop where, let's say an AI system, I'm not saying it will, but let's say it goes rogue and it's doing things that it shouldn't be doing. Let's say we design an AI system that's supposed to defend our networks, but it goes outside of our networks and it starts violating all of our authorities because obviously you can't be doing that because that's now some of the offensive cyber, right? And we don't have the authority to do that under defensive operations. Or do we? Setting you up. So if it goes rogue, is there a kill switch that shuts the system down? Is there something that will pause the system? Is there a system that will automatically alert, for instance, that AI SOC model? Will it alert the AI SOC and say, hey, there's something going on here, we need to pause operations and ensure that we are. So not saying that the adversary could possibly get into into the code itself or get into the libraries. I'm being a little bit facetious there. They will. If there's a way, there's a way. There's a will, there's a way, yeah. So yes, that's how I would approach it from the coding side of the house. But, there's the whole piece of cyber defense. You don't throw the baby out with the water. You still do cyber defense. You'd still do cyber threat hunting, proactive, and you still, looking for APTs operating in our networks that are trying to compromise maybe our AI system, that is a SOC as an example. We still do incident management, tier 1, 2, 3. We still do forensic malware, and another key thing is reducing your footprint, attack surface management reduction. It's a combination, and I like to call it integrated defensive cyber operations. Oh, by the way, should be intel, ops, and signal, all together integrated, working together as a team to solve this problem.
Great. And if you can keep your mic on, and because you are legacy, maybe I can ask you this question: what are the best practices for securing legacy operational technology systems in the modern AI platforms without introducing new vulnerabilities?
Wow, that's a great question. I think
Your legacy, right?
I
That's
want to
why.
defer my 30 seconds, yield 30 seconds to Lori on this one.
Thank you,
Go ahead.
Colonel Blando. I just want to piggyback on something he said, actually. So we've talked a lot about the challenges of AI, and it is really important to understand that there are foundational things that AI can really help with, like he mentioned, using and incorporating basic functions to help free up resources to do other functions is a great thing. We've seen more and more cyber defenders using AI actually as a quality control thing. So SOC outputs, some organizations are using all of the information that their analysts are manually doing. They're creating a model of all of the things that have ever happened, and then they're running AI models on top of that to validate every function and action that a human takes moving forward. And what that does is it gains, again, the big piece is trust and quality and accuracy of the information that we're doing, and allows us to then repurpose some of those resources to do other functions. One thing that is extremely important, and I think has been a little bit of an overarching theme, is the continuous validation and vetting of what's happening with your models. So as you are reallocating resources and thinking about the future of your organization and what you're going to do, it's very helpful to, again, use AI modeling in ways that it's going to be accurate and helpful, and then repurposing people to senior analysts who are very good at what they were doing, who may have been slightly displaced because of some of this capability. They can be your verification and your validation team, your red team against AI modeling. You can use these people to come back and check and ensure that the outputs that are happening continue to be good, and to validate the data. I'm just going to ask a question. How many in here have asked a question of ChatGPT, specifically ChatGPT? Raise your hand. Right. Okay. 80%, maybe 90% of the room. So here's the thing. Okay, I'm going to ask a second question. How many in here have asked ChatGPT a question about something they know the answer to? Okay, less. So you know how to challenge these models, right? And if you are an organization and you are implementing AI into your business plan, you know who you can point out to challenge these models, to challenge the data, to challenge the things for the efficacy of what you're trying to do. Many of us know the questions. I'm a supply chain defense analyst. I look at this. If I ask it about CVEs and I say how many CVEs did came out in the last month, you have a general idea of that. If it gives you the false answer, number one, as experts in your field, where to go for authoritative sources for that actual number. So really what I'm trying to say here is there's great power in using AI, and we already know how to make sure that we are not getting erroneous outcomes for that. Now, again, when you go to the public sector and you're talking about critical infrastructure and you're talking about large scale infrastructure, there are more challenges. However, we've all been doing this a long time. In your space that you are an expert in, you know who to call on to ask those questions. And I challenge you, in 5 or 6 questions, you can probably make an assessment if the output of what you're trying to do is accurate. And you can gradiate that on tasks, right? Low-level tasks, you can absolutely validate that very quickly. And then as you move up into higher level outputs that you're looking to gain from AI usage, then that's where you maybe have more specialized teams. But I don't even know if I answered your question because you deflected to me. But again,
that was some useful insight, I think. But again, I think legacy operational technology is a challenge we all face. And I think that's where we're trying to get those understanding of how you help in the labor. Maybe you can, based on your experience, You have been in this field for or 10 years in this location. How would you address that?
Yeah, I get all the hard questions.
Yeah.
So there's a good question here about operational technology. And it's important to think about what does it do and what are the risks to it? And more importantly, what are the costs to attack it, right? It does us no good to completely leave our operational technology completely insecure. That's probably bad. But it's also probably bad to spend $1 billion securing our operational technology if nobody is actually, substantively, making plans to attack it. So the important thing here is, look at the scope, figure out, what any security expert, you have to have a threat model of who is potentially attacking you, right? As somebody who works for the U.S. Army, I think a lot about other nation states and what they're doing. Other industries may either they may think less of nation states, or they just may not have the budget to worry about nation states, depending on where they're at. So that's a factor. And then, also maybe you can have the same effect just by segmenting and building resilience, right? If I have a system that is critical, and it's really, really, really expensive to secure it, maybe I can just build 2 or 3 more. And if the first one goes down, I just bring a second one in, and that pops in, and that, either way, like I've addressed the risk, I've fixed the problem, and I've found another way to solve it that doesn't necessarily involve cyber. So thinking intelligently about that, and thinking, sometimes accepting the risk makes sense, sometimes thinking about reliability makes sense, and then sometimes actually securing makes sense. And these are all hard challenges that a CISO has to worry about on a daily basis.
So with that, if I can follow that up with another question, Colonel Hasbrook, is with the conversion of AI with advanced networking like 5G at the tactical edge, and we spoke a little bit about that earlier, how does it impact data security and governance paradigms for distributed autonomous systems?
Okay, that was like 6 buzzwords in one sentence.
Yes. Yes.
Yeah, buzzword bingo. So I mean, wireless is obviously something that we think about a lot, right? So wired versus wireless has always been a trade-off. Obviously, for a lot of reasons, you would prefer to have wireless, but there's a lot of reasons why we don't have wireless, because it is nowhere near as reliable, and in the field, you need reliable comms, right? So 5G helps a bit in the sense that it can do more, it is slightly more reliable, it has slightly more, it's slightly better than 4G, which is slightly better than other things that came before it. But still in the end, it probably doesn't have the scope you need for autonomous operation. So largely what you're going to see with autonomous operation is you're going to see some things that do use that level of technology. And then you're going to see some other things that still require a fixed wire line. And you're already seeing this with drones today, where you see some drones that are still operating using cellular technology. You're seeing some more short-range type drones that are literally just running a spool of fiber optic cable from where they're launched, so that they can't be jammed by some kind of EW type effect. And then other drones doing other things, which I can't really talk about in this forum. So there are lots of different ways that you can approach the problem, and it's not a one-size-fits-all situation.
Thanks. And Colonel Lando, you spoke about satellite data in an earlier conversation. So if you can just talk
absolutely.
about that.
So think about how AI can assist you, enable someone that is charged with developing a program protection plan for a satellite system. I'll tell you, it took me roughly, with support, 6 to 8 months to actually write that entire program protection plan. Now, what that consisted of is doing an entire decomposition of the entire system. Imagine that. Breaking it all the way down to the components, breaking it all the way down to the critical processing, that is being done to understand the vulnerabilities associated with that. Understanding the supply chain risk management, gray market devices, developing an anti-tampering plan, developing a cybersecurity plan, developing an OPSEC plan, because all that stuff it's very unique because I got to watch a satellite actually assembled, and it's a very sanitized process. Very cool if you ever get the chance. Also developing a classification guide. So let's take an AI system and give it that particular requirement. I need you to develop a program protection plan for this satellite system. Could probably put it together in a very short period of time. For a human, it took me 6 to 8 months with resources. Some of the challenges, obviously you have to look at all, again, I'll just go right back to vet, validate, and verify every one of those libraries, right? But what I think is really cool is the ability to decomposition of every single component all the way down to the component level, and then start analyzing, especially when it comes to the supply chain risk management side of the house. Where was that component made? I'll give you another analogy. Sometimes we accept data as, like Lori was saying, and Lieutenant Colonel over there was saying, sometimes we accept data, but we can't just accept data on the granted of data. I mean, it's like your water supply. Would you accept a new water supply that was being pumped in that you've never had done before, and they somehow changed it? No, you're going to make sure that that water supply is safe, because you're going to verify that the water supply is safe because it's for you, yourself, and your family, right? It's like building a new well. Well, you're going to get that well tested before you start drinking it, right? I hope you do, because if you don't, you never know, could be sulfur in it or something. Anyways, I just say that as an example because I have a cabin up in Mountain, Wisconsin. I just got a well. Anyways, just trying to give you some real life experience. But hopefully that answers you on the satellite piece of the house on how AI can actually enable and optimize the efficiency of developing a program protection plan for such a complex system.
Thank you. And if you can keep your questions ready, we're going to go into, in the next 5 minutes, we'll wind up and get a couple of questions from the audience. And just quickly, Laurie, maybe you can talk a little bit about red team and continuous validation processes in certifying AI models.
You are really giving me all the wonderful questions. Validating AI models. I mean, I talked a little bit about it. You can do third-party validation models. Something that I'm sure you guys are hearing to talk about buzzwords is AI bombs. So understanding your bill of materials, much like Glando was talking about. Where did it come from? Which pieces came from where? And continuing to be able to trust and validate what you're using and the outcome of it. I do want to talk about one piece of this that I think the supply chain and just the implementation and incorporation is that we do need to treat it like any other process of any other thing that we're inserting into our network, into our process, into our utilization. Not everybody needs to have access to everything. So as you are using these models, as you are training these models, and your users are inherently training your models, you need to be careful on who you are using to do that. The second that you get or insert adversarial data into it, like this is a statistic that I'm sure you guys have seen, it's like 0.01% of data poisoning can can absolutely destroy your model, like up to 80% or something of the efficacy of it. So just like you wouldn't give the keys to the kingdom to, maybe your gate guard, you want to kind of protect your data and your modeling the same way, again, so that you continue to have valid models. The other thing Lieutenant Colonel Husbrook talked about a little bit. So having an autonomous system isn't doesn't totally completely work for most of us. You need to have external input into your model, because if you don't, eventually you're going to have bias, right? And I know I did talk about segmenting it and sectoring it off and maybe having specificity into your models. But if you are just having a general model, and you're going to have external influences on that. So you're going to ingest new data, you're going to train on that, you're going to train your models on that. It's important for you to, again, protect your data. Data gives you the operational advantage, whether that's economically or defensively or whatever it is. So you want to make sure that you, again, protect the different streams of your data, make sure that the people using the data are not poisoning your data. You want to make sure that you don't have any actual adversaries who are trying to affect your data. And when you're shipping your data out or sharing your data or getting updates to your data, if it's not your own data sources and you're building it out, you want to also make sure that you are trying to do data aggregation and things like that. And again, I know it's a little bit off topic of validating it, but at the end of the day, it's kind of a team sport, right? You're going to hope and believe that the data that you are getting from, others to ingest into your system, that you do trust it. But again, trust but validate. I'm sure we've all heard these buzzwords. Yeah. And then again, internal, it's going to be a challenge, right? I mean, in all spaces, on how to make sure that you maintain the integrity of your data, maintain the integrity of the output of your data, maintain the integrity of the relationships that you have with others that you're sharing the data. So all of that to say, yeah, data aggregation at your edge will probably be one of your biggest tools to help with, reduction of risk and things like that when you're coming
Thank
to
you,
AI.
Lori.
Yes.
So, Colonel Hasbrook, last question to kind of round this up is, if you could quickly talk in your role about AI workforce requirements. What kind of workforce do you think we need to get in for AI, data quality, and stuff like that? If you can quickly comment on that.
I wanted to have one thought that I take off of what Lori was saying here, and then I'll address the AI workforce question. So in talking with some CTOs at various organizations, there were a lot of them who were telling me that, hey, so we adopted LLMs like internal to our organization, and then about a third of them were like, and we did that for 3 months and then we stopped. And I was like, well, why did you stop? Because this is everybody's hot new thing. Like, what happened? And almost in every case, it was because that they did not do the work ahead of time in properly segmenting the data that was available to the model. So if you're in an organization that is very open in sharing, then no problem. But if you're in an organization that's very regimented and hierarchical, and Unit A doesn't need to know what Unit B is doing, and Unit B doesn't, it sounds good on paper that everybody knows everything that's going on and you can ask the model any questions. But when people start asking hey, how much salary does Janie make? And, do I make more than her? Or what is the confidential business strategy that hasn't been announced yet? What is it? And the model will just tell you, because it doesn't know to keep those things to itself, right? It doesn't have, so those pilots all had to be pulled back and then re-scoped and different business units all had to have their own ones. And so this is kind of the point I'm talking about is a lot of these newer tools, AI, I hate the term AI because it's just a broad umbrella term that could literally mean anything. There's a famous quote that says, AI is for the stuff that we don't know how to do yet. Once we know how to do it, it's just software. And I think that applies here. For the things that we don't know how to do yet, right? I would love to see a workforce that has some basic understanding of statistics and data analysis, and understand what are when you're asking questions, what is the realm of results that makes sense, and what is the realm of results that doesn't make sense, and when do you need to probe deeper? One of the things that I am most worried about when it comes to implementing LLMs for security use cases, but this applies to any use case, is that a lot of the existing warning signals or red flags that you're used to seeing about, hold on, this might be low quality, let's check it, those don't exist anymore, right? We're used to, if I handed this off to somebody who maybe wasn't the best at doing the work and I got it back and it was full of typos or grammar errors, I could say, okay, if the typos or grammar errors are here, maybe the analysis isn't that good either. I need to double check. But now LLMs will very happily give you a incredibly perfectly formatted, no typos, no grammar errors. But guess what? The data is completely wrong. And it is much harder to tell that from context clues than it used to be before. So understanding that and sussing it out, please use the ChatGPT, and so you can figure out when not to use it, I think is my biggest talking point.
Perfect, thank you. We'll take a couple of questions from the audience before we wind up the panel. Please raise your hand, I can point you out. Yes, sir.
Absolutely. So, I mean, if anybody was tracking what happened in Australia, that law firm that orchestrated the totality of their case based off of AI, and they were wrong. The judgment was executed based off of this information, and then they are now being sued, I believe, by the Australian government or something like that. So here, that is fundamentally the problem. You have to, okay, I'm really going to get, hopefully most of you have used this. It is critically important that you actually understand the tool that you're using. So when you are using it, you need to ground it. It needs to have no hallucination. And I'm going to tell you right now, whatever you believe, listen to this, hallucinations have been trained into the model. It is not making it up. It is not a sentient being. The hallucinations that you are seeing when you have put it all the way down to nothing and say, do not hallucinate, it means that the training has been bad. And you're going to see that a lot in these publicly accessible AI models. You have to, especially if you're using a model for your specific function. So you're training this model to understand what you're trying to do and have an output that is accurate, reliable, and validated. We have to red team this. Like, again, going back to cybersecurity 101, we red team our systems. I know red teaming is not popular or hot anymore or sexy and nobody does it because everybody's perfect. I know we all are. But like, we need to do this with AI. It's critically important that we red team our outputs of our models. I mean, again, to your point, it's like, sure, it's super fun to ask ChatGPT what the top 5 restaurants are in the local area. There's no repercussion from that. If you're asking ChatGPT, I know we're not using ChatGPT at a public level, but if you're asking ChatGPT, tell me the 3 biggest exploits that are running on my system or something like that. I mean, there's national security implications, things like that. You have to use this tool with responsibility, I guess.
Let me get to another question
okay.
before we wind up. Yes, sir, at the back.
To the panel in general, how is this methodology and this concern going to influence the next level of Advana?
Advana, okay.
Yeah, like how is this, concern of this methodology going to transfer to that transformation of the data that is in that repository and how it's being fed, right, quality data into that? Because right now it's just a repository of everything. So they're trying to, transform it into something. What's your take on that? Where's the next level on that? Is that in your scope from cyber?
Yeah. So I will go outside my scope a little bit. So keep that in mind. That this is, what you're hearing from me is worth what you paid for it. But I will say Advana and the thing. So for those of you who don't know, that is the large data repository that is storing quite a bit of data, not security data, but just data in general for the Army enterprise. Yeah, and DoD and across the board, right? So recall earlier I said that Army tends to be later to enterprise trends than industry does. So industry definitely had their, if you think of the Gartner hype cycle, they had their modern data stack, data science, like they went through the hype and then they went through the disillusionment and now they're doing it. I will say on the Army side, we've been through the hype on the data science cycle and we're starting to enter the disillusionment part of it when we start to realize that like, this is all really hard. And then, and now we're also going to overlay LLMs, which are a completely different technology on top of that, which is separate from some of the existing data science and data challenges that we had before. I don't have good answers for where it's going to go, but I do think over time you're going to see some of the leadership who is going to be more AI aware and perhaps possibly less data science aware, different backgrounds of where they come from. You're going to see that trend go more in that direction, if that makes sense.
Last question, and then obviously the panelists are here to answer, go on one-on-ones. Yes, sir, in the back there.
I did not plan this question.
So, curious, what if I don't have to poison your data? What if your data is already the bad data? Right?
1 out of 3 models already have an implanted.
Thinking about from a DoD perspective, right? Most of the policies contradict each other, and there's not really good cyber policies currently to govern about this. So, if you feed all that data into AI, if people are making decisions based on that DoD data that contradicts itself, where are we at with trying to cover something where everybody's kind of fighting in? In the last year, all these companies all of a sudden added AI.
Right.
None of us have evaluated the actual neural networks and how they weigh data.
Right.
We're just wrapping our training models
Into
tools.
each
So
other,
How
yeah.
do we reach governance when everybody's already?
It's outpaced it. I mean, we talked about this earlier, and so we need to roll it back. I'm going to let him answer it from a public sector side of the house, but I can tell you right now, like, there are mechanisms that you can put in place. There's a financial institution that they have an AI model and it's looking for anomalies. And if the anomalies happen, it immediately shuts off and it fails closed. We have this stuff. We are not ignorant on how to securely administrate things. We need to pause and maybe be not so overly reliant on the beautiful, magical AI and really step back and again, use those free time that you have now that you have code that's getting written for you and Google searches for you and research happening and take some people and reallocate them. In the private sector, this massive layoff that is freeing up resources, instead of letting those people go, they should be taking the experts and reinserting them to be doing some of this really critical validation piece that we all know. It's foundational to so many different processes. Over to you for the...
Okay, so I'll give the more optimistic take compared to that take, which is humans make mistakes too, okay? Humans have always made mistakes. We are used to humans making mistakes. We hold computers to a higher standard, and we probably should. But we should also, anytime you are looking at an assessment of a AI system that is performing a task, if there is not a line on that graph that says, what does the baseline average human do at this task, given the same inputs and outputs of the model in the same time frames, you need to be actually comparing apples for apples, right? If the model makes, if it makes mistakes 10% of the time, but the average human makes mistakes 40% of the time, then it might still be worth it to implement the model. But then you have a much broader question about organizational culture, which I don't have time to get to today. But yeah, there is both positives and negatives, and it's things that the leaders of today and the leaders of tomorrow will have to address as we see where this technology goes.
Thank you. And with that, we end of the panel. Thank you so much for your time, and thank you to the panelists.